Almost got all the clips and other stuff cleaned out of here that I want. And I want to show you guys this little bolt. It's actually a lag bolt that floats on top of the lead. Look at that. Isn't that something? It just shows you how dense this stuff really is. So this is not just a melting point demonstration, it's a density demonstration. I can push my spoon all the way down in there, but that stuff just floats on top. Incredible. Okay, we're gonna get this stuff cleaned off. Now I want to leave the black stuff is mostly the leftovers of the wood shavings that I put in there. I'm going to leave that in there. It'll help keep the lead from oxidizing. Maybe you can see that little gray stuff that starts to appear on the surface. That's not cool. Okay, so what we're doing here is we're pouring ingots. Okay, and this lead, it's not pure lead. It's an alloy. It's got some tin and some antimony and maybe some arsenic in it. But it's got all of the impurities removed, or most of them. And the reason we do that now is because, you know, once it gets to the lead pot, it will not want to flow through the little spout on the bottom if it's really impure. There's a lot of junk in there. So I try to get as much of that out at this stage as I can. Okay. Yeah, and plus it just makes my job easier at the other end. You know, you got to melt it down anyway. So, and I got that one a little too full. Okay, so molten metal. Pretty sweet, huh? I want to show you guys how much energy is in this stuff. Okay, it is so dense and it has absorbed so much energy. Takes it almost as long to cool down as it does to heat up. I'm gonna go ahead and finish this pan here real quick. I'll show you guys what I'm talking about. And you can kind of see. We're gonna go ahead and get all these little pieces put into the. Oh, it's stuck. Alright, so this is still a little bit liquid. And you definitely do not want to pour any water on here. It will flash boil, and if it gets in between the lead's liquid and the surface, it will explode. So, there it is. We're going to very carefully pour some water in from the side here, and hopefully that will help to solidify some of this stuff before we put some more water on it. Check it out. So you can kind of hear the popping sound. That's when that water gets down between the solid lead and the pan there. It occupies about 1,000 times the volume as a gas, so it's got an awful lot of power. Respect the power. It's just incredible how much water it takes to cool this stuff down. Like I said, you do not want to mix water with molten lead. That is a good way of getting a face full of it. Getting closer here. So this pan, so in other words, this pan has to be completely dry before I pour more lead into it. Man, like a sauna. Well, eventually those will cool down. I'll put them over here. I don't know if you guys can see this, but that's not like what you would think of as a shiny metal. Maybe you can see some of the crystals that have formed at the surface. Oh, here's maybe a good one. There you go. Can you see that? Those crystals are antimony and arsenic and stuff. So that tells you that this is not pure lead, but it's an alloy that's a little bit harder and it's suitable for making bullets in 9mm, 44 Magnum, 45 ACP, that kind of stuff.